Hello dear students. So today I will take the next topic, that is necessity of starter in induction motor. So what is the purpose of using the starters in induction motor? So that is the topic. So we know that in a three-phase induction motor, the magnitude of induced EMF in the rotor depends upon the slip of the induction motor. Whatever the EMF is induced in the rotor, that is absolutely depends upon what? Slip of the induction motor. So, but what is slip? At starting condition, the value of slip is at its maximum equal to unity. Why? Because we know that slip equation is S is equal to ns minus n by ns. At starting condition means what? When the motor is not running, means when the shaft is not running. When the shaft is not running, at that condition n is equal to 0. That is the actual speed. Ns is the synchronous speed, that is the speed of rotating magnetic field. Okay, at starting condition we can say theoretically n is equal to 0. So at this condition, if you substitute n is equal to 0, what will get? Ns will be get cancelled, so only will get 1, that is slip will be 1, means unity at starting condition. So because of the slip at starting condition, the large EMF gets induced in the rotor because the relative speed between the rotor and rotating magnetic field is very high, that is maximum. So therefore, as the rotor conductors are short circuited in most of the motors due to the squirrel cage type construction, so this EMF, induced EMF, circulates very high current through rotor at starting condition. So we are discussing here at starting conditions, we can say that a large EMF is induced because of the slip is maximum, and whenever the EMF is induced, the current will flow in the rotor, so that current will be very high which flows in the rotor initial at the starting condition. Hence, as rotor current is high at starting condition, consequently the stator draws very high current of the order of 5 to 8 times full load current at the starting condition. It means that at initial condition, the stator draws 5 to 8 times the full load current. Example, if the motor is carrying capacity of 5 ampere, then initially the motor carries a current of 5 times, means 5 into 5, 25 amperes is flowing on the rotor circuit. So obviously, due to such high current at starting condition, there is a possibility of damage of the motor winding. So to avoid such effects, it is very much necessary to limit the starting current drawn by the motor. Hence, the starter is very much necessary for the induction motor. So in simple way, to limit the starting current, so the starters are necessary, because at starting condition the current is very high. So we need to limit the current to minimum. For that purpose, the starter is necessary for the induction motor. So let us discuss the type of starters used in the induction motor. For your syllabus, the star delta starter is in there, but many other starters are used for the to, to control the starting current of the induction motor. So this is the block diagram of the star delta starter. The name of the starter is star delta. So we know that the three-phase connection can be done in star or delta. So that's the name is star delta, means initial condition is initially the stator winding is connected in star, afterwards it is shifted to delta. Okay, let us discuss working of the star delta starter. So here you can see three-phase AC supply, RYB three-phase, and here running condition means when the motor is running at its full load speed or more than 50%, that we can call as a running condition. And at starting means when the just supply is given to the motor, at that point the starting condition. So here we are using the TPDT switch, that is triple pole double through switch. So the function of this switch is which connects the stator winding in star connection in star at the starting condition, and also it shifts the stator winding in running condition, that is in delta. So during at starting condition, the stator winding runs in the star connected winding, and under the running condition, the stator winding runs in the delta connected stator winding. Hence, this starter is most suitable only for those motors designed with the delta connected stator winding running. So those motors are capable to run under the delta connected stator winding. So how this star delta starter works? So this is the rotor. Normally we are using 99% of the motors are squirrel cage construction type. That is the rotor, this is stator, and this is input supply, and this is the main TPDT switch. Okay, so when the switch is in the start position, the stator winding gets connected in star. So when the switch is in the when this TPDT switch is in the start position, then the stator winding is connected in star connected winding. Okay, so what happens in star? So we know that in star condition, the line currents is equal to phase currents, and the line voltage is equal to √3 times phase voltage. So whenever the motor is running in the star condition, so at that condition, the phase voltage is reduced by 1 by √3 factor. So that is VPH is equal to VL by √3. Means if you are giving the supply voltage 440 volt, then 440 divided by √3, so around 254 volt you will get across each phase. Across this phase, if you measure the voltage across this phase, 254 volt, 254 volt, 254 volt, even though you are giving the voltage of 440 volt supply. So it reduces by 1 by √3 times. So the phase voltage is reduced by 1 by √3, that is VPH is equal to VL by √3 when the stator winding is connected in star. This is only at starting condition. So because of this voltage reduced by 1 by √3 factor, the current is also get reduced by the 1 by √3, so that initially we can reduce the high current flow to the rotor circuit. Next, when the motor reaches 50 to 60% of its rated speed, then the switch, TPDT switch, triple pole double through switch, is thrown in the running position. So that is when the motor picks up, the rotor is rotating 50 to 60% of its rated speed. In that condition, this TPDT switch automatically switches from this these three terminals are shifted to here, RYB, that is running condition. So here what happens? This is a delta connected winding. So in the delta what happens? VL is equal to VPH. So if you are giving 440 voltage input supply, then the phase voltage is also 440. So same voltage you will get across each phase. That is the rated voltage you can get at the each phase of the stator winding. So that the operation of this switch is taken place automatically with the help of relays. At starting condition, it switches to the start condition. At running condition, it switches to the delta. So that's the name is star delta starter. Star means at starting condition, delta means under the running condition. So the overall function of the star delta starter is to reduce the starting current, or to limit the starting current to the induction motor. Hence we can protect the winding against the high current flow at the starting condition.